Hello all, welcome back to Electronic Device and Circuits video lecture series. I am BVV Sachinarayana, Associate Professor in Department of ECE, Vishnu Institute of Technology, Bhimavaram. In unit number 3, Rectifiers and Filters, we already discussed about introduction to RPS, basic rectifier setup, half-wave rectifier, center-tapped full-wave rectifier. Now, in this lecture, I am trying to give some brief details about bridge rectifier. Bridge rectifier. The objectives of this lecture are the circuit diagram of bridge full wave rectifier, operation of bridge full wave rectifier, waveforms of bridge full wave rectifier. In center tapped full wave rectifier, there is a center tapped transformer and two diodes. In center tapped transformer, the tapping location should be exactly at the center. Then only in the secondary, we are getting two equal magnitude and opposite phases signals so as to drive two diodes. But it is somewhat difficult to identify that tapping location. In our bridge rectifier, there is no need of center tapped transformer. Peak inverse voltage of diode used in center tapped full wave rectifier is 2Vm. Since in the secondary, there are two equal magnitude and opposite phase signals, Vm and Vm, the total 2Vm is dropped across the reverse bias diode. So the peak inverse voltage is 2Vm in center tapped full wave rectifier. Whereas for bridge rectifier, the PIV of the diode used is Vm only. 4 diodes are required in bridge rectifier. These 4 diodes are arranged in the form of an electrical bridge. And center tapped transformer can be replaced by using this electrical bridge. Bridge consists of 4 arms and each individual arm consists of one diode. To one diagonal of the bridge, AC input signal is applied through the transformer and the rectified DC is taken from the other diagonal. Similar to center tapped full wave rectifier, in bridge rectifier also, both positive and negative off cycles are rectified. For both positive and negative off cycles, the direction of current flow in the load must be the same direction. Then only the negative off cycle, it can be converted into positive off cycle, and both positive and negative off cycles are rectified. And coming to the circuit diagram, the figure represents the circuit diagram of bridge full wave rectifier, which consists of a transformer, step down transformer. The number of turns in the primary is greater than that of the number of turns in the secondary. And a bridge, electrical bridge, which consists of 4 arms and each arm consists of one diode. And one diagonal, I'm calling it as A and B, is connected to the secondary of the transformer. And the other diagonal, C and D, we are getting the rectified DC voltage, which is applied to the load RL. So here the arrangement of the load is very, very important. I already told the load must be arranged in such a way that current flowing through the load during positive and negative off cycles must have the same direction. Coming to operation, during positive off cycle of the input AC signal, this upper terminal A is positive with respect to lower terminal B, and this positive is connected to anode of D1 and negative is connected to cathode of D2. So the diodes D1 and D2 are forward biased and can conduct. And the remaining two diodes D3 and D4 are reverse biased. So these two diodes doesn't conduct, can act as open circuit. And if you draw the current direction, let me take a different color. So current direction, we are always representing from positive terminal to the negative terminal. Here it is the positive terminal. The current starts here and flowing like this, and it is flowing through the diode D1, then and going to the load and flowing like this through the load. Then it is flowing through the diode D2 and it is back to the negative terminal. So current we are always representing from positive terminal of the battery to the negative terminal. So some load current is flowing through some current is flowing through the load. So a positive off cycle is developed across the load for positive input cycle. And coming to the negative off cycle, during the negative off cycle of the input AC signal, upper terminal A is negative with respect to lower terminal B. So, and this negative is connected to cathode of D4 and positive is connected to anode of D3. So, D3 and D4 both are forward biased and these two can conduct. And the diodes D1 and D2 are reverse biased. So, these two doesn't conduct, can act as open circuited. Okay, then I'm trying to represent the current flow. So, as I already told, current direction always represented from positive terminal of the battery to the negative terminal. So the lower terminal is the positive now. So the current starts here, positive terminal, and it is flowing through the diode D3. Then it can flow through the load. Then flowing through the diode D4 and back to the negative terminal. This is the current direction during negative off cycle of the input in the bridge rectifier circuit. Here the direction of current during positive off cycle, during negative off cycle is same. So this negative input cycle, the negative off cycle of the input is converted to positive off cycle. Okay, during positive off cycle, a positive off cycle is developed across the load. During negative off cycle of the input also, a positive off cycle is developed across the load since the current direction is same during both positive and negative off cycles. So there is a full load current for full input cycle. And coming to the waveforms of bridge rectifier. So the waveforms of bridge rectifier is same as that of the center tapped full wave rectifier. So the first waveform is input AC. And the second waveform is the current flowing through the diodes 1 and 2. And the third waveform is current flowing through diodes 3 and 4. And fourth waveform is the total load current IL equal to ID12 plus ID34. And the last waveform is the load voltage. So during positive off cycle of the input, diodes D1 and D2 are forward biased and hence conduct. So we are getting a positive off cycle. So at the same time, the diodes D3 and D4 are reverse biased. It doesn't conduct. So current equal to 0. And during negative off cycle of the inputs, diode D1 and D2 are reverse biased. Doesn't conduct. So current equal to 0. And during the same negative off cycle, diodes D3 and D4 are forward biased, so it can conduct. So we are getting a positive off cycle. So why we are getting a positive off cycle for negative means the current flowing through the load is in the same direction as that of the positive off cycle. Okay, and the same cycle repeats. Here also same cycle repeats. Now, if you want the load current for one complete cycle, full cycle, then add ID1, 2 and ID3, 4. So in IL, we are getting all positive of cycles. If you add these two, here we are getting a positive of cycle. If you add these two, we are getting a positive of cycle. So all are positive of cycle. Means negative of cycle, it is converted to positive. So that is because of the arrangement of load. The current direction in the load for positive and negative of cycles is same. Then load voltage VL equal to IL into RL. As RL is constant, VL is proportional to IL. So VL is also having all positive of cycles. If you want, you can draw the voltage drop across the diode also. Here there are 4 diodes, and at any time 2 diodes are forward biased and 2 diodes are reverse biased. Across the transformer secondary, we are getting a VM, and that VM is dropped across the uh, reverse bias. 2 reverse biased diodes, both are in parallel. That's why the peak inverse voltage of each diode is VM only. Whereas in center taper transformer, based full wave rectifier, the peak inverse voltage is 2 VM. Our input AC signal is bidirectional. So with this bridge rectifier, we are converting into the unidirectional. Still, our output, it consists of more AC component. That's why this output, we can call it as a pulsating DC. It's not perfect DC, which is pulsating in nature. Then coming to the summary. In this lecture, we have learned the following: the circuit diagram of bridge rectifier, operation of bridge full wave rectifier, and waveforms of bridge full wave rectifier. Thank you. Thank you all.